Providing a quick video here to clarify some of the things that we went over in the last class on constant rate of change and proportional relationships. So it turns out that there is a section on this topic in your textbook. It is in chapter 9. And so you can go there for reference, and we'll look at a couple of problems here from your book and try to clear up maybe a little bit of the possible confusion that there was in the last lesson. So we talked about rate of change. The rate of change is the ratio of the change in the y value or output value divided by the change in the x or input value. And we kind of went over a couple of these examples. We use the Greek letter delta to represent change. So we are looking at delta y divided by delta x. That's what these numbers are here. So the y changes by 12, the x changes by 2. So your constant rate of change, because it's always the same here in this problem, the rate of change, the ratio is always 6 feet per second, 12 divided by 2. Okay. So here is an example for you, a quick one. We'll keep the problem simple at this point. So what is the constant rate of change for this table? And it should include units. Well, you should recognize that the days goes up by 1 each time. So you can do a little plus 1, plus 1, plus 1 if you wanted to write that out here. These are each going up by that. And then down here, change this color. The money goes minus 20 from 100 to 80, and then from 80 to 60, it goes down 20 again, and then from 60 to 40, down 20 again. And so your rate of change is minus 20 divided by 1, which is minus $20 per day. You can also find the rate of change from a graph. If the graph is a straight line, then the rate of change is constant. And it doesn't matter which points you use to find the constant rate of change. Now, there are two problems on this graph. So the example that's done out here is on circle 1, the green line. And so the way to find the constant rate of change from a graph is to pick 2 points on the graph and find the change in y, okay, which would be this vertical change here between these 2 points, and divide it by the change in x, which is this horizontal change between the 2 points. And we'll talk more about that in the next lesson, next part of the lesson. But for now, if we pick the values here, you can sort of make your own little table of 2 values. Okay, so x value of 2 and a y value of 5, that's the point right here, and an x value of 6 and a y value of 4. So that's where these came from. You just took those off the graph. And so then you can find the change in y value, that's 4 minus 5, down here, change in y, over the change in x, 6 minus 2. 4 minus 5 over 6 minus 2 is 1, a change of negative 1 centimeter for a change in 4 seconds, right? So the centimeters radius goes down 1 for an increase of 4 seconds, meaning that the rate of change for this graph, circle number 1, is negative 1/4 centimeters per second, or negative 0.25 centimeters per second. And this is like an advertisement that has 2 circles moving on it, so that it means that the radius of the circle 1, is decreasing at 0.25 centimeters per second. All right, so let's take a look at circle number 2. That's your got it problem. Circle number 2, what is the constant rate of change? The first step here is to select 2 points on circle number 2. I'm going to pick these two here. We'll talk about that. There are easier ones maybe you could pick, but I'm going to pick this point 2, 3, 2 seconds, 3 centimeters, and 4 seconds and 6 centimeters. Okay, so these are the two. These are ordered pairs, or if you wrote them out in a table, the X and Y values that go together. So the change in the Y is 6 minus 3, which is 3. And the change in the X is 2 seconds, 4 minus 2. That's here. Okay, so that means that the rate of change here is 3 over 2, or divide that and get 1.5 centimeters per second. So what that means for circle number 2, is that the circle is expanding at 1.5 centimeters per second. This is a positive rate of change. Okay. Now, I want to look at circle 2 a little bit more here, and this is kind of going out of the book, but something we talked about in the last class. So both of these circles show linear relationships because their graphs are straight lines. If the graph is a straight line, the relationship has a constant rate of change. It is a linear relationship. Okay, so linear, constant rate of change, straight line graph, those are all mean the same thing. Now, circle 2, different than circle 1, not only is circle 2 linear, but it also goes through the origin, which means that we know from previous discussion that circle 2 is also a proportional relationship. A proportional relationship not only has a constant rate of change because it's a straight line, but it goes through the point 0, 0. Okay. And you will also find that the Y value divided by the X value for any point on that line is going to be the same value. That is always going to be the same, Y divided by X. It is also going to be the constant rate of change. But you can kind of see if you used 0, 0 as one of your points here, then 2 seconds and an increase of 3 centimeters, that's going to be the rate of change, 3 centimeters every 2 seconds. So if you think about it with a table here, okay, if I take the points here for circle 2, 0, 0, and then 2, 3, and then 4, 6, and then over here 6 seconds and 9 centimeters, right? Every time I divide the Y divided by X, centimeters divided by seconds, it'll always come out to 1.5. That is called the constant of proportionality, which we have seen in the previous lesson. It is also the same thing as the rate of change, because in a proportional relationship, the rate of change and the constant of proportionality are the same number. They are also the unit rate, right? The rate of the expansion of this circle is 1.5 centimeters per second. That's a unit rate. So these things are all the same. In a proportional relationship, the division or the ratio of Y divided by X, output divided by input values, equals the ratio of the change in Y divided by the change in X. That's the rate of change. And that is called also the unit rate. Okay, so these are all just the same value in these relationships. Okay, so there's an IXL topic here that you're going to do for identifying the constant of proportionality. So in this example, it's a food company, and they're talking about the ounces of almonds and the ounces of dark chocolate in this trail mix. Okay, so to find the constant of proportionality, which is the same thing as the rate of change, you find the X and Y values that go together. You can just pick a point on the graph. It's 2 ounces of almonds and 1 ounce of dark chocolate. So the constant of proportionality is 2 ounces of almonds per ounce of dark chocolate. That'd be your answer for that one. Okay, so there's a bunch of these to do. If the graph is a straight line that goes through the origin, then this is how you can find the constant of proportionality. It is also the same thing as the rate of change. One final thing to talk about on rate of change. Rate of change can be positive, meaning as the x value goes up, the y value also goes up. Okay, and your graph would go up as you go from left to right. Or it could be a negative rate of change, meaning as the x value goes up, in this case, as time goes up, the temperature goes down. Or maybe the y value doesn't change at all. In that case, it has a 0 rate of change. As time goes on here, the temperature stays the same. The rate of change is 0. All right, I think that's it for now. And you have some practice problems to do on constant rate of change. Then we will look at the next part of this concept in the next lesson.